representation of the vector because it has a picture with it. Probably not able to do your problem because it had a picture. So before I work it, I'm going to talk about the setup of the picture because there may be some on your homework where you have to set up the picture. So the first word we need to talk about is a bearing, and you've seen it in your textbook. There are two different ways bearings are represented depending on the textbook and depending on who's writing the problem. The ones you saw in your textbook earlier in the year said north 15 degrees west, and so you would go from due north 15 degrees to the west. This doesn't give you any information like that, and when that's the case, it's always from due north to the east. Textbooks that don't give you any other information go from due north to the east. So it says a ship leaves port on a bearing of 25 degrees. So going from due north 25 degrees to the east. And travels 61.4 kilometers. So do we have a vector? We have a direction and a distance. So we have a vector. And then it turns due east and travels 84.6 kilometers due east. How far is the ship from port? So we have two vectors acting on each other. We have one going on the 25-degree bearing, and then we have the east-bound vector, right, the one going straight due east. I want to know what the resultant vector is, the two vectors, how they are working together, those two forces working together. So, how do you do a resultant vector from yesterday? How do you set up the picture? You're doing a resultant vector. Draw two lines. How? Tip to tail, right? Either the parallelogram or tip to tail, because we want to put those to where we're getting that resultant vector, the A plus B vector. So notice the picture already did that for you. That's what makes the problem workable without having knowledge of applications of vectors. So they took those two vectors and put the tip to tail, the resultant vector, the red or pink one. It is what I'm trying to find how far the ship is from port. How'd you do it?
Square root of a squared plus b squared.
Good, law of cosines, right? So the square root, so find this distance. If you want to call it A, you can, or if you want to call it the length of a vector, you can. Let's see how you set that up. Square root of 61.4 squared plus 84.6 squared minus 2, so 61.4 plus 84.6 cosine of 115 degrees. Did we get it? Wait, what? Any questions about how far from port? I've asked what is the bearing from port, and again, we needed a little information on that. You may or may not have answered that question correctly, and that's okay because you didn't know what a bearing was. But it's the angle from due north to the east. So how can I find that? Find the other angle APE, right? So we want to find this angle and then add 25 degrees. How do you find that angle? You can use the law of sines. Do we have any worry with the law of sines not giving us the correct angle on this? Why not? It's already an obtuse angle. We know what law of sines struggles with obtuse angles because sine inverse gives you obtuse angles. So
115.
good, and use that calculator stored value for A to keep your accuracy. Perfect. And what do you get for B? 38. That is in degrees. Make sure your calculator's in degrees when you run that. Because I want the direction angle from due north. If we're sticking with the way they gave us the direction, I want the direction from due north. So add 25 to that. So 68. So the ship is on a, let's see, the ship is on a bearing of 63. Any questions on that one? Okay. I've set this one up picture-wise too. The next one I'm going to have you set it up. So this is an airplane, another bearing problem. Wants to work with vectors. A plane with an airspeed of 355 miles an hour is headed on a bearing of 62 degrees. A west wind is blowing. If you didn't know what a west wind was, there's nothing to chance there, and they told you. At 28.5 miles per hour. The ground speed and the actual bearing of the plane. So this is an interesting problem. I mentioned it yesterday when we talked about vectors, that airplanes are something where resultant vectors come into play a lot because we've got wind involved in our direction. So we have two vectors. This time, what's the magnitude that they give us? The magnitude of the vector. It's in miles per hour. So the magnitude of the vector is a quantity. It doesn't necessarily mean it's a distance. It can be any quantity with direction. So in this case, the vector is a speed. We have a 355 mile per hour vector on a bearing of 62 degrees and a wind that's going from the west to the east. So we're going to put those two vectors tip to tail again to look at the resultant vector. So we have the 355, the 28.5, and the resultant vector. I'm going to find the ground speed and the bearing of the plane. What do they not give me that last time I had pretty easily? They don't give me an angle. I'll give you a second. Minute.
If you put particulars on a line straight across, then it would be 62 degrees. And you can find the other one, and then it's perfect.
Does everyone see how she did that? So you have a triangle, a right triangle made with due north. How do we know it's a right triangle? Well, it's yes, right? So west and north. Last time I checked, that makes a right angle. I like that. And so we can find 90 minus 62, which is
28.
And then we can find that other angle, which would be supplementary. And that gives us enough to work with on our vector picture, like our tip to tail vectors. 152 degrees. That is enough to use the law of cosines to find the speed of the plane. The plane's magnitude will be the speed, since all of the other magnitudes are speed. That third magnitude will also be a speed. So 28.5, 355. Someone with a calculator. Point what? 399. So is kind of a tailwind. Now, it's not a perfect tailwind, but it's kind of a tailwind. So it makes sense that that would speed up. Is that a question you should ask yourself when you're working word problems? Back it off. Okay, does this answer make sense? If not, question, what did I do? What do I need to change? All of that fun stuff. Okay, now what do I need to find? Angle. And which angle would be beneficial to answer the very question?
A little bitty tiny.
Yes, I agree. Angle, is that the name there? COB? Angle COB. Angle O in the triangle. And so, how am I going to find that?
Law of signs.
Law of signs. Good. Is there any question about the law of signs being made? I know, you get tired of hearing me say that, but we have to ask that question. If we're going to use the law of signs, we have to say, okay, is it going to cause us any problems? Should we just go use the law of cosines, or do we have to worry about that? And how do you know you don't have to worry about law of signs messing up? I already have one obtuse angle. I can't have two obtuse angles in a triangle, so I'm good to go. Sine of O over 28 equals.
Sine of 152.
Okay. So I'm going to leave that as x. Use that value from your calculator.
Oh yeah, I was wrong. I was wrong. 2.0.
I should be wrong.
I don't know.
Let's find out.
I think I did cosines.
Okay. Is that my answer? What do I need to do to get the answer? Add that to 62 degrees, and why do I want to add that to 62 degrees? Okay, go back up. Back up to the picture. The original bearing was 62, and then we've been pushed farther over. Now you can envision a problem where we're pushed farther backwards, and we might have to subtract, depending on the problem. We've been pushed farther over. And so, what is it, 64? What is it exactly, 62? That's our bigger question. Later for a heavy start out. This one is kind of set up for you also. So of course in navigation, direction, vectors are applicable. It's also a thing when you're working with forces in your physics classes. So read this one. See which state. Thank you. He's taking care. Okay, so I want to find that magnitude on the bottom. It's a right triangle. So what did you say we could use? Okay, good. Cosine. Just plain old regular cosine will do. You could do the law of sines or cosines if you wanted, but I don't want to. So cosine of 50 degrees is x over 100. I've got news. 100 cosine of 50, which is
100 cosine of 50,
76.6.
0.4443.
Please forget those.
76.6.
What would my units be? get that?
I didn't get that.
I didn't get 60. I got 64 for the two.
What was it?
64.279.
Pounds, right? Because we're going to have the same units on our vectors. And so it asked me to find the work done. Good thing they told me what work was, in case I didn't know. Force times distance. I have 60 pounds, 64 pounds of force. What's my distance that I'm going across the floor? 30 feet times 64.279 pounds. What's the number that you get? What would my units be? I don't know anything about work. I'm not a physics person. What would my units be? So have y'all ever heard that unit in physics? It's a foot pound. Work is measured in foot pounds. Well, why mathematically? Because you multiply 85 pounds, you get foot pounds, whatever that is. Okay, I want to see if you can set an airplane problem. Oh, don't. No, it's not an option. Drop it. Okay. What did you do? Okay. And they use the word heading instead of bearing. Textbook difference. That goes with the same thing. So we have an airplane from due north on a bearing of 60 degrees. What does that mean? 60 degrees from the north to the east, right? So I have a 60-degree angle there. And this is a magnitude of 450. That's what they all tell me. Maybe. Okay, and the wind is blowing from the north. So what's that mean? So I have a vector that looks like this. Now, where am I going to put it? It's a tail with the other one. So you have result of vectorizing. That's it. Tail with the other one. You could also draw a parallelogram. Did anyone pick the parallelogram option yesterday on homework? Or did we all do something? You did the parallelogram. So you also have that option. If you want to draw the parallelogram here, it will give you the same. Do what? Both. They both work great. That's a magnitude of 42 miles per hour. So this is...
Steph, I need your attention for just a second. We've had to move tomorrow's app schedule to Thursday. Tomorrow we will be on regular schedule, and then we will have app on Thursday. I apologize for the inconvenience, but we'll just switch that one day. I also sent you an email regarding it. Thank you.
Thanks, yeah, they both are. Yeah.
Alright, now we can ask.
Y'all are doing pretty awesome. I'm impressed. Okay. Mr. Bridges, he's our curriculum. No, he's the tech guy from tech. Remember I told you he was coming?
Was he good?
The state has like makes them come in and just check up on. I mean, since you're getting college credit for this, I gotta make sure I'm teaching you something. Okay. Now what? Now what?
60 degrees, not 150.
Why is it 60 degrees?
90-degree angle to restart your computer.
It's time. So we're gonna have to use geometry. There's no, there's no setup the same for every problem. But don't we have north and south lines that are parallel? So we have two parallel lines cut by a transversal. So this would be alternate interior angles. This would also be 60 degrees. Wait, how did you do that? Oh. Or you could do other things.
You figure out the other end is 30.
Okay, so let me say this one more time, and then we'll go with the triangle option. But we need to agree this and this are parallel. North-south lines. And this is a transversal. And alternate interior angles. So that's one way to do it. The other way is I'll draw a triangle here. Okay, 90, 60. You could find this would be 30.
Yeah.
But then this adds up to be 90. It's a right angle, not a horizontal line. So either way works great. I don't care how you did it, as long as you got that angle to be 60. Yeah, the right one is 30, 60. I don't know that this one's right, so I'm just going to go with the 60. So C is the square root of 42 squared plus 450 squared minus 2 is 42. That was 450. Cosine 60 is what? Okay, and let's do a quick check. Does that make sense? It does. I'm going 450 miles an hour, but that wind is working against me this time, isn't it? So the wind slows me down a little bit. Any questions so far? Does this really happen in the real world?
No.
The wind doesn't.
If the wind's blowing in your favor, your flight will get to your destination faster. It's just the way it is, right? So if the wind's blowing against you, you will get there slower. Any frequent travelers here? So have you noticed that sometimes you'll take the same flight? They're much, much faster and much, much slower depending on... Okay. Any questions so far? Find the angle. Just what? Someone said it had
64.
64 what?
846.
Does anyone need me to work that? You did. So we'll do the side of A over 42. You set it up that way. Try it again.
Okay.
Oh, good. Amazing. Y'all can hear me for now. So okay. He's a professor.
Who is the professor?
I think he's a math professor. I think he might be the math professor.
Yeah, that's me.
That's true.
Did you get 4
Yeah.
this time? And it's easy.
All these pretty much the same.
Okay. Just want to see what we had left.
Here.
Okay. I don't know how many of these I'm going to do the actual math on, but I want to set them all up. So you see the setup that work for everyone. Y'all can handle the law. Cosine, start, cosine, start. Just set up a few more. Okay. So this one's interesting. I think there's one in your homework. One of the bars is being towed by 2 locomotives. The magnitude of the resultant is 6,000 pounds directed along the axis of the barge. Find the tension of the tow lines if each make an 18-degree angle with the axis of the barge. This one's a tough one because it's a little different. It gives us the resultant vector's magnitude, 6,000. But what is that? Well, we know this is traveling on a straight path, right?
Yeah.
So the resultant is the straight path that it travels on. And it's 6,000. There's 6,000 pounds of force. What that means is that the tip to tail, I have this vector pulling this way and this vector pulling this way. If I put those tip to tail, and you agree I get something kind of like that, that would put me back on. What I want to know is the tension, the pounds on each of the ropes. So that's what I'm looking for.
Because it's an 18-degree angle, so isn't that like right there? Left or right?
Those are both 18, right?
Draw a straight line from the 6,000. They make.
Because this is tip to tail, right? Wouldn't you agree that, what's this, 36?
That's good.
What was that?
90 minus 36.
180 minus 30, because the parallelogram, you remember that from last night's homework? 144. That's 144 degrees. What's this? 18. You probably figured that out already. But if you hadn't figured that out, which does let me know, since this is an isosceles triangle, if I find either one of those, I have it. I'm done. So all I need to do is find one of them. If the barges weren't pulling at the same, the same force, then it wouldn't go straight, would it? Because if one's pulling harder, it's going to go crooked. So it makes sense that they're going to have the same, but hey, we verified mathematically that that's the case. But, so what would you use? I use the law sign.
You don't have to figure it out.
It's actually, I don't think.
I should have done it backwards, but that's okay.
Boom.
Someone solved that for us. Well, oh yeah, we said we weren't going to do that. You did it good? What'd you get?
3,154.
So it makes sense that they both are. Now, somebody might say, well, why isn't it not both 3,000? They're very good. They're off to the side. They're not straight on, so they're going to have to pull a little harder to get that 6,000 pounds of force on that vector. Does that make sense?
On the plain ones, what if it's over 90?
What if that's overnight? The bearing? Good question. Question is, what if the bearing's over 90 on a plane problem? So say it's
110.
110. That's the problem.
Awesome. This one's good. This is 120 miles per hour.
Right? Would it be going 110 degrees would be 20 degrees past 90? Okay? So that would be your plane. Past the. Oh,
long stop goes up. Which is the theme.
Like you would draw a south wind.
Yeah, but you put it on the top.
You want them to tell, right?
Like northeast is the
All right. All right. I just wanted to set these up. The non-physics person in me, the first time I saw one of these, it was tough. Maybe you physics people might laugh at me for that. It's not bad now, but I remember the first time I saw one, I thought it was tough. Find the force required to keep a 2,500 pound car parked on hill.
Too many right angles.
So what we need is we need the force going up the hill to be 2,500, right? 2,500 pounds. So any questions about that so far? Yeah. So the car's weight is 2,500 pounds. I need to know the force. The car's weight is 2,500 pounds. I'm looking for the magnitude of the pink line. That's what I want to know, the magnitude of the pink line. The car's weight, which is due to gravity, so it's a straight down force, is 2,500 pounds. Does that make sense?
Yeah.
I'm going to put those tip to tail. So I'm going to take this vector here, put it tip to tail, the straight down force of the car from gravity going straight down. Got a question? So the car's weight is pulling straight down. So gravity. So this is a vertical line. So the car weighs 2,500 pounds. That force due to gravity is 2,500 pounds. I need to know this force to keep it up on the same line. So I'm putting it to tell it to make my triangle. That's all I've done so far. Now I need to figure out the angles. They did tell me the angles, but I know that we need to talk about them. Where'd they get those? How do they know that's 12 degrees? I know
12 degrees.
I know how they know that one's 12 degrees. But I do need to figure out how they got that to that triangle.
So they put that triangle with the
Well, how?
yeah, but it's because that's what you take to tell you. You just move it. You just click on it. My copy things.
Okay, good. Let's talk about that. We do have some perpendicular things. First of all, I know this is perpendicular with the ground. We agree gravity is perpendicular with the ground. So I can find angle B, 90 minus 12 would give me angle B, 78. Right. Okay.
And that other makes it right.
The other one, the resultant, ends up making a right triangle with the incline. And so this is also 90 degrees. So all three of those add up to 180. So that would do some subtraction. That's where you get that 12. Now once I get the picture set up, and the good thing about these, the math person in me likes that all the pictures of these look the same, so you can kind of shortcut some things after you've seen one. But the right triangle makes things easy. Why does the right triangle make things easy? I've got Pythagorean theorem, I've got all sides, I've got sine, cosine, and tangent. So I really want to know what it's called side B. I want to know side B. The force it would take to keep the car up on that. So opposite and hypotenuse. Sine of 12 degrees equals B over 2,500. Multiplied by 2,500. I don't know that you can have any of these on your homework. I just put one because I remember it. Your homework report is the vector word problems. A lot of questions. There's a large problem, just like the part we did.